Hello. So I'm not in there, but all we're doing today is something that is straight review from Algebra 2. About the beginning of Algebra 2, so complex numbers and things like that. Um, you probably felt great with this when you were in Algebra 2, which means you should be good here. We are only going to do one day of this review and do a quiz next class. However, I promise you, the practice that you do today, if you can do it, you will be able to do the quiz without an issue. So we're going to go ahead and get started. Complex numbers are related to vectors in the fact that you have a vertical component and a horizontal component the same way you do with any kind of ordered pair. So we are going to talk about operations, adding, subtracting, multiplying, dividing. We're also going to talk about graphing, which is super simple. And then we're going to talk about finding the modulus, which is really just the distance between the origin and your complex number, your point. Okay, so if you were to graph it and you were to find the distance between the origin and the point, that's what the modulus is. It's really finding the absolute value as well. So we're going to start with operations with complex numbers, adding, subtracting, multiplying, dividing. To add and subtract, simply combine the real numbers using the operation, okay? And then the imaginary numbers using the operation. Real numbers have no I with them. Imaginary numbers have I. All of your complex numbers should be in the form A plus B I, where the real number, okay, is first and the imaginary number is second. Everything should always be in that form. So you can see in example 1, we've got 3i minus 2 plus 4 plus 6i. Okay, we have to figure out what the real numbers are. Well, 3 and 4 are real numbers, so the numbers that don't have I in them. So what's 3 plus 4? 7. Then our imaginary terms, negative 2i, positive 6i. Again, imaginary terms have I in them. Pretty straightforward. Negative 2i plus 6i would be positive 4i. It is that simple, guys. It's basically combining like terms when you're working with addition and subtraction. The only thing that I tend to have issues with, keep in mind, I taught Algebra 2 for several years. I taught pre-cal for several years. So we always are kind of doing this. I've seen a lot of the problems. Comes in subtraction. With subtraction, a lot of people forget that you're subtracting. They go to add it the way they did in example 1. You have to remember that you're subtracting. So we've got our real terms, 4 and negative 2. What is 4 minus negative 2? Well, that's really 4 plus 2, so you should have said 6. Then you've got negative I and 3i. Negative I minus 3i. So I've already gone 1 negative. I need to go 3 more. Negative 4i. If you're struggling with this, it probably means that there's some kind of issue with just really adding and subtracting integers, positive and negative numbers. In that case, I suggest that you go to your calculator. Okay, make sure it's plugging in correctly, but I suggest you let your calculator do the work. Adding and subtracting, I don't think we're going to have issues with. You're probably looking at it and like, yeah, I remember this. Multiply. Again, don't have that many issues with it. You can either use box or FOIL the same way you did when you were multiplying binomials, just normal binomials. I don't care which one you use. It's totally up to you. I was taught FOIL when I was in high school. I've always used FOIL until I started teaching and kids taught me box and I thought it was great and it was organized. I'm going to do one of the examples box and one of the examples FOIL. I think the big part where a lot of people forget is that you can't have I squared. If you have I squared, you have to change it to negative 1. So I'm just going to go ahead and I'm going to do number 3 with box method. You're welcome to do both with box method. Again, I'm going to do one in box, one in FOIL, but whatever you know works for you, do that in your notes. So with box method, it's just like creating a Punnett square in biology when you were talking about genetics. Take your first one, and it can go to the side or it can go across the top. I always put it across the side, making sure that I keep the sign. Since that 3i was negative, it needs to stay negative. Negative 2, negative 5i. I'm just going to go through and multiply. So when you're working on this box right here, you take what's above it, you multiply it by what's beside it. So 4 times negative 2 is negative 8. Again, moving over, take what's above and what's beside. 4 times negative 5i is negative 20i. Negative 3i or times negative 2, I'm sorry, is 6i. I get a lot of people every once in a while who get things like that wrong just because you don't think about the fact that you have a double negative. Creates a positive. Then you've got negative 3i times negative 5i. Negative 3 times negative 5 is 15. I times I is I squared. Okay? So I'm going to come through. I know that these are like terms. So instead of writing them separately, I am going to go ahead and combine them as I write this mathematical sentence out. So I've got negative 8. I've got 6i minus 20i, which is negative 14i. And I've got positive 15i squared. Well, we highlighted I squared is equal to negative 1. You can't leave I squared. So I'm going to come in here, and I'm going to put a set of parentheses and change I squared to negative 1. 15 times negative 1 is really negative 15. And now I've got these like terms. Look at this. Negative 8, negative 15 that I can combine. Negative 8 minus 15 is negative 23. And then the negative 14i just gets to carry down. And there's my answer. Box is great if you really need that visual organization for math, whereas FOIL gets a little bit more, I don't want to say disorganized, but it's not the same. Okay. Remember, if you're using FOIL, it stands for first, outer, inner, last. It tells you how to multiply the numbers, which numbers get multiplied together first. So if you know that you want to do box, do example 4 using box method. If you knew that you wanted to use FOIL, you should have done example 3 as FOIL method. Practice whatever method you are going to use on our quiz. I'm going to do FOIL here. First, so I multiply the first two numbers. Negative 2 times negative 4 is positive 8. Outer, so I multiply the two outer numbers. Negative 2 times 3i is negative 6i. Inner, the two inside numbers, negative 7i times negative 4 is positive 28i. Then last, the two last numbers, negative 7i times 3i, that's negative 21i squared. I really hope y'all can't hear the people screaming outside my door. Y'all, come on, like, go home. Really. I mean, don't hang around. Go home. We know that I squared cannot stick around, just like the kids outside my door. So we have to change I squared to negative 1. Negative 21 times negative 1 is positive 21. Then we just have a big jumble of common terms. You have 8 and 21. You have 8 and 21. You got negative 6i and positive 28i. So 8 times, or 8 plus 21, I'm sorry, is 29. Negative 6i plus 28i is positive 22i. So either box or FOIL, I don't care which one you want to use. This is FOIL. This is box. Whichever one you felt more comfortable with in Algebra 1 and Algebra 2 is probably the best one for you at this point. I don't want to tell you you have to use one if you know that you're more comfortable with the other. You've schooled on this long enough, you know what you need. So I'm not going to be picky about that. The biggest problem that I see is people forgetting that I squared is equal to negative 1. Do not leave I squared in your answer. You also talked about dividing when you were way back then in Algebra 2. I went ahead and wrote out the steps, but you have seen dividing before. Okay. One of the first steps of dividing is that you have to find what's called the complex conjugate of the denominator. Find the denominator, the lower part of the fraction. Find the imaginary term and change its sign. Don't touch the real term. The real term stays exactly as it is. The term that doesn't have I, don't change it. The term, sorry, in a term that has I, change the sign. You're not going to change the number, just the sign. Once you have found the complex conjugate, you are going to multiply the top and bottom, the numerator and the denominator, by that complex conjugate. We're going to use either box or FOIL. Whatever you used last time in examples 3 and 4, stick with that. Sometimes you just get to distribute, which is nice. Okay, if you've got one number times two numbers, you're just going to distribute. But if you have two numbers times two numbers, you're going to box or FOIL. Personally, in this aspect, unless I've got a lot of room, like I've got a good bit of room here, so I'm going to go ahead and box. But unless I have a lot of room, I would probably go ahead and FOIL for these, because that's a lot of room that you're going to be using to organize if you're using box. Once everything is multiplied together, combine like terms across the top, combine like terms across the bottom, and then simplify if necessary. This is a fraction, which means it has to be in simplest form. So if every number can be divided by something, you need to reduce it. So example 5, complex conjugate of the denominator. I'm going to look at the denominator, which is negative 3i. It is an imaginary number. There's no real numbers here, which means I need to change the sign of negative 3i. What's the sign, or it's the opposite of negative 3i? Positive 3i. So my numerator and my denominator are going to get multiplied by that. The reason you have to multiply by the complex conjugate is that it will cancel I out in the denominator. I represents the square root of negative 1, okay, in case you forgot. Also, in case you forgot, you cannot have a radical in the denominator of a fraction. It's not allowed. So having I in the radical, or having I, sorry, in the denominator is having a radical. So it's got to go away. We can't have I in the denominator. Multiplying by complex conjugate alleviates that. So I'm going to handle my numerator. I'm just going to multiply it out. I've got 3i times 4, which is 12i. I also have 3i times 2i, which is 6i squared. Then I've got my denominator. Okay, negative 3 times positive 3 is negative 9. I times I is I squared. Now we know we can't have I squared. I squared has to be changed to negative 1. I see I squared on top. I also see I squared on the bottom, so I'm going to change them both. Then I'm going to come in, I'm going to multiply what I need to. Okay, I've got 12i minus 6 and positive 9. But remember, in the first part, I told you that your real number needs to come first. So I need to swap the top. There's no like terms to combine here. Okay, we can't combine the negative 6 on top with the 9 on bottom. They're in like separate rooms. You can't put them together. So I have to see if there's simplification that can happen. You should be looking at negative 6, 12, and 9 and saying those can be divided by 3. So I'm going to reduce. There's my answer. Yes, 2 and 4 can both be divided by 2, but we're not going to go there. It needs to be all three numbers that you're looking at that can be divided in order to keep going. So let's kind of draw myself a barrier. Number 6 is going to take a little bit more time, a little bit more work. That is because you have a binomial on bottom. You don't just have a single monomial, single number, the way you did in example 5. So I'm going to have to still come in, find the complex conjugate. I've got positive 2 plus 3i. The imaginary part of that is 3i. I have positive 3i, so I have to change that to the opposite sign, which is negative 3i. That real number, the negative 2, I'm sorry, does not get changed. Do not touch the real number. I am writing the wrong thing. That's Alright, so I'm going to make a thinner pencil, and we're going to start multiplying. This one, I'm going to have a different box for the top and a different box for the bottom. The exact same way when I multiplied over here, okay? I've got to multiply on the other side, but because I have two binomials, I've got to do box or FOIL. So I'm going to do, label it. Here's going to be the box for the top. Here's going to be the box for the bottom. I have found, both with myself and when I was teaching Algebra 2, I found that kind of labeling these helped to keep them straight for both myself and students. Okay, so let's look at the top. I've got 3 minus 2i, and I've got negative 2 minus 3i. Okay. For the bottom, I've got negative 2 and a positive 3i, and then a negative 2 and a negative 3i. Again, it doesn't matter what you put across the top or across the side. When you multiply it together, it's the same anyway. Let's start filling in the box for the top. I've got 3 times negative 2, that's negative 6. I've got 3 times negative 3i, that's negative 9i. I have negative 2i times negative 2, which is 4i. I've got negative 2i times negative 3i, which is 6i squared. And guys, if I'm going too fast, you can pause this at any time. Then on the bottom, I've got negative 2 times negative 2. Sorry, I had to pause for the get out. It's 2:30 announcement. So negative 2 times negative 2 is positive 4. Negative 2 times negative 3i is 6i. 3i times negative 2i is negative 6i. And then 3i times negative 3i is negative 9i squared. So I'm just going to kind of combine like terms and write things out at the same time. Negative 6, and then I've got my like terms here. And when I get to this part, I'll have them here. So that's negative 5i, and then plus 6i squared. 4, and then these cancel out, so I don't have any of that. I just have negative 9i squared. We know I squared can't be a thing. We've got to change I squared to negative 1. I've got negative 6 minus 5i minus 6. I've got 4 minus negative 9. Negative 6 is negative 12 minus 5i. 4 minus negative 9 is really 4 plus 9, which is 13. So now what I'm going to do is I'm going to take this, which is the top, this, which is the bottom, and put it together. I'm going to do it way up here. Negative 12 minus 5i over 13. That can't be reduced. I'm done. Okay. If you were using foil, it's going to be a little bit different. And I know I said I was going to use foil to kind of take up less space, but I ended up being able to do it just because my pencil was thinner and it's not that big a deal. But if you wanted to use foil, you would use foil the exact same way that you did back in steps or examples 3 and 4. So that is all review. You have seen all of that before. You did all of that in Algebra 2. The back of this page is where we kind of come in with pre-cal and build onto what you did in Algebra 2. It is not hard. Really, 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 it's going to be fun. Talking about graphing. To graph, simply take your complex number and convert it into an ordered pair. The real term is your x, the imaginary term is your y, plot the ordered pair. So 4, negative 3i, it turns into 4, comma, negative 3. 4, negative 3. You have plotted the complex number. That is really it, guys. Example 8 is a little bit different just because we don't have both of these parts, okay? I have a real number, and I was told that my real number is going to be x, but I don't have an imaginary number. Well, what's the value that represents you not having something? 0. So I can just come to negative 2, 0. Plot a point. Okay. Again, real numbers, think about them like your x's. Imaginary terms, think about your y's. That is it to graphing complex numbers. Make it an ordered pair, plot it. That's it, guys. Don't make it any harder than that. Find the modulus. Man, if I look at these directions, I'm not even going to necessarily read these directions. Look at that formula. That is the distance formula. That is the formula that you've been using to find the magnitude of a vector. That is the formula that you use a little bit differently to find the hypotenuse of a triangle. Okay, I told you this formula just kind of keeps coming back and we just give it different names. For this, it's called the modulus. This is basically how you find the absolute value of a complex number. The exact same way that you did back in graphing, you're going to kind of take this and make it an ordered pair. Okay, Your real term is still your x, your imaginary term is still your y. Now we're just going to go for it and plug it in. 9 squared plus negative 3 squared. Well, 9 squared is 81. 3 squared is negative 3 squared is 9. So that is the square root of 90. If I wanted to simplify that, that would break down into the square root of 9 times the square root of 10. 9 times 10 is 90. The square root of 9 is 3. I cannot take the square root of 10, so it stays. 3 rad 10, or 3 radical 10, or 3 root 10, however you want to say it. Okay. Example 10, do the exact same thing. Negative 2 comma 4. Negative 2 squared plus 4 squared. Negative 2 squared is 4. 4 squared is 16. I've got the square root of 20. Well, I could break the square root of 20 down into the square root of 4 times the square root of 5. Square root of 4 is 2. Square root of 5 cannot be determined, so it sticks around. You're not always going to be able to simplify a radical, guys, but in the event that you can, and if it's a huge thing, don't go looking for, problems. But if it's something, from 200 down, you really should be simplifying the radicals. Okay, that is it. We're at 21 minutes, so the entire lesson in 21 minutes, that's fine. You have got a worksheet that I promise you, if you can do the worksheet, you can do the quiz. Some of you might pick up on what I'm saying about that, but I promise you it's going to be okay. I've also put the answer key up on the board. You might have already seen it. You might have already taken a picture of it, whatever. Keep in mind, you must show your work in order to get credit. Don't forget. You can see that there's some work to be done. So I will see you guys later. Have a wonderful weekend. And I will see you Tuesday for your quiz on this. Bye, guys.